I'm back. Here we go. So we need to talk about some filler material. Now, in order to understand how things work, we need to discuss specifications and classifications. Okay. So the American Welding Society, or AWS, has been around for about 100 years. They set codes and standards like rules and regulations to a game. Okay. So a specification has a spec in it. And imagine a big barrel as your specification. The specification is A5.18, and it is the specification for carbon steel electrodes and rods for gas shielded arc welding. It encompasses all the electrodes that are carbon steel for GMAW. Okay? Now, imagine on the inside is a bunch of little boxes. And these little boxes represent all the different rods and electrodes that are used for GMAW. Okay? Each box is a classification. For example, ER70S-2, okay? And it must meet those standards of the specification and specifically the classification. So this is a classification. Really, a classification is kind of like a secret code, okay? And you need the decoder read this knowledge. So once you do, it makes it really easy to understand the electrode or the rod that you're going to use as long as you understand this code, okay? All right, so let's talk about this. So the first letter is E. E stands for electrode. So what is an electrode? An electrode means the electricity is carried through this. This can be a cut wire or rolled up wire that carries the electricity and deposits metal. Now R. R stands for rod. A rod can be a rolled piece or wire, but the electricity doesn't go through it. We're just using it as filler metal. Okay. Now the first two numbers right here. Okay, these tell me tensile strength in thousands of pounds per square inch. This is how much force is pulling this apart. Okay, and the usual tensile strengths are around 60, 70, 80, 90, 100, or 110,000 psi. Okay, so in our example, it's 70, so the tensile strength is 70,000 psi. Now, the next letter, S, stands for solid. Okay, there could be other letters here. The letter T stands for tubular, which is used for FCAW. There can also be the letter C, which is for composite materials, and those are used for specialty and production materials. And then after that, there's an X. The X is actually a placeholder, and there'll be numbers after that dash that tell the user the composition or what's been added to this. Okay, so there's a 2, a 3, 4, 5, 6, or 7. So if we look on this chart here, all right, so here it is, ER, electrode rod, 70,000, solid wire, and it says 2. High in silicon and manganese deoxidizers, contains aluminum, titanium, zirconium deoxidizers, and can be used for single and multi-pass welds. Well, usually we use ER70S-6, and then we can also look at different specifications. Well, this is AWS A5.28. This is for low alloy steel electrodes. A510, aluminum. A59, bare stainless wire. Okay. A5.7, copper. Okay. So now we can kind of see how things work. So let's go back. Now, so some of you guys have taken my class before and you understand the rules that can be virtually applied to every situation. So let's go over the rules for those that don't know them. Rule number 1, match the base metal with the filler metal, which means steel with steel, aluminum with aluminum, and so on. Rule number 2, we want our welds as strong or stronger than our base material, meaning we want to make sure our tensile strength is stronger tensile strength than our base metal. And rule number 3, 90% of what we do is based on thickness of material. So when we're choosing a rod, diameter, or even amperage, we're judging it upon the thickness of the base metal and what we're going to need. So, I regress. Let's look at the slide. So, tell me how we're going to choose the diameter of your wire or electrode. You guessed it, thickness of material. So, for now, let's look at 1/4 inch. Okay, so GMAW comes in sizes from Remember this is on a test. 0.023 inches all the way up to 1/16 of an inch. Okay, so this chart kind of ballparks thicknesses, diameters, volts, and amperages for you to use. It's not a, hey, you have to use this. This gives you an idea of what you can run at. Okay, so let's look at what we're using in class. In lab, we're using 0.035 wire. This means that I have to have a contact tip for 0.035 wire and rollers that are 0.035. Okay, otherwise it might not work very well. All right, so we're looking at 0.035 and it can be used for different thicknesses of metal. If you look, here it is, 0.035, 0.035, 0.035. So we can see it's a pretty good all around. Okay, now, so those of you who struggle with decimals, this is a time for you to practice. So 0.125 equals 1/8 of an inch, and 0.250 equals 1/4 inch. So notice that it's not really meant for really thick metal. Okay, so GMAW was designed for thinner metals that have less than 200 amps. Okay, so we can see that the volts are about 19 and 20, and the amps are about 140 to 200. Now, this is not an amperage knob on the machine, so how do we set amperage? Well, amperage and wire feed are together. So when we talk about amps with the wire feeder, it is relational to the wire feed speed. This doesn't mean we're setting it 200 amps though. It's a percentage of the wire feed speed that relates to amps. All right, points to remember. Remember, DCEP provides deep penetration and excellent cleaning action. GMAW requires a CV or a constant voltage welding machine. We need to make sure that the wire feed speed is set for the current that is to be used. Stick out is a distance the welding wire projects from the end of the nozzle of the welding gun. Proper nozzle to work distance must be maintained to ensure an adequate shielding gas. Okay? Use of CO2 as shielding gas is most effective and least expensive when welding steel. Argon produces most effective results when we weld aluminum. And for most welding, the gas rate is between 20 and 35 CFH. We need to make sure that the correct wire diameter must be used to ensure a quality weld, and we want to make sure that we follow the manufacturer recommendations for wire diameters. All right, guys, as well, take care.